Hi gang, welcome to another video on mechanical science. What we're going to do today is just going to have a little look at introduction to fluid systems. So looking at some definitions and some fundamental concepts. So you can see the power of fluid here and the amount of force that you can actually generate with it. So stick with us and we'll hopefully expand your knowledge and see how we go. Okay, so some terminology here. Now I've got a series of videos coming up on fluids and how to solve problems in fluids. So this bits of terminology is going to help you sort of get your head around it. Now I've also got an individual video on density, so you can check that out. Archimedes principle, you might have heard of that guy when you've been at school, and then obviously we'll tie that up with trying to solve some problems as we work our way through. Hydrostatic thrust. Now we're going to kind of concentrate on the areas for assessment, and if we cover any additional areas then great. But some basic principles of fluids, and I've listed them. There's 5 of them that I've identified here. There's other sort of more complex things going on with fluids, but these are the kind of basics. So fluids have no fixed shape, so you imagine you fill a water bottle up, the water takes the shape of that bottle itself, so depending on what the object is whatever shape fluid you're going to end up with. Pressure at a given depth in a fluid is equal in all directions. So what that means is, if we have a little example here, if we've got an object, pressure at this point is equal to the pressure at that point, and there and there. Alright, so pressure is equal in all directions. Okay, so pressure increases as the fluid and the deeper you move into it. Again, you'll have experienced that. You've had a ball in a swimming pool. You push it down, you've got what's called a buoyant force in opposite direction. So the further that ball goes in, the more buoyant force, so the greater the pressure. Fluids and forces can change depending on the shape they're being contained within. So in this case, the force at the bottom of this would be dependent on the shape of the container. If it's a square container, then that would determine the force as well. So depending on what the shape it is would depend on what area you use to calculate that. And last but not least, gases can be compressed and liquids can't. So that's why we bring gas in on the ship from far off flung places around the world, because we can make it smaller, put it on a ship, bring it to Britain, expand it, and then we can use it for whatever means is possible. So yeah, some basics there. Now I've also put the more common formulas up here that you're going to be using, and you'll see some of the terminology we mentioned in the last section there, and we'll be investigating these a little bit more in depth. So just get used to these terminology. Continuity, so it means it's the same on both sides, as you can see here. Both sides, and then continuity at both sides. And we're going to be looking at units, examples and all that jazz. But to get our head around these, so if we go back to those formulas, there's a few new bits in there that we might not recognise. But to get our head around these, I put a little table together. So I'm not going to run through all of these, but you can see, that should actually be a 3 there, kilogram meters cubed. Well spotted for anybody who saw that. So density, kilograms meters cubed, mass, gravity, right, and don't forget our gravitational value is 9.81. Force, same as when we did statics, force is in newtons, height is in meters. Now I put an H and an X there. Some formulas you'll see will be rho GH and some will say rho GX, but height is always in meters regardless of that. Area, meters squared. We've got 2 V's here, big V, volume, small v, velocity. So keep your eye out on that when you come to solving these problems. Obviously these two are very, very different. So we need to be aware of that when we're solving problems with that. Tends to be volume goes with density, and velocity goes with area, but we'll worry about that at a later date. Mass flow rate, kilogram meters per second. So it's basically telling us how much of a mass of a material is coming out of if you've turned the tap on, how much mass is coming out per second. Volume flow rate, in relation to volume, you turn your tap on, how much water comes out in relation to volume. meters cubed per second, and then weight ties in with force, which is also in newtons. Okay, so keep an eye out on all of this that's coming up. Now, so we've got quite a number of formulas that we're going to have to get our head around here. Some of which we've done before. You know, you've done density previously, you've done force is equals to mass times gravity. But there's some new ones here. So in relation to hydrostatic thrust, so this is a new one. Yeah, volumetric flow is a new one. Continuity of flow. Now these two are closely linked to one another. All right, so keep an eye out on these. Now I've left the units as depending on what you're calculating. Yeah, so if I'm using the continuity of flow, I might be calculating the area of an object. So obviously my units would be meters squared, or I might be calculating the velocity of an object. So my units would be meters per second. And I've done the same for continuity of mass flow. All right. So these again, the continuity of flow and continuity of mass flow are very closely linked. As you can see, you've got density, area, velocity equals density, area, velocity. All right, so keep your eye out for upcoming videos on this series. But we will be solving quite a few problems with these. So hopefully these will start to make sense for you. All right, so again, I'm just going to reiterate this. This is, for density is volume, and this is velocity. It's a common mistake that people make, so bear that in mind. All right. So check out the next videos in the playlist on how to solve problems in fluid systems. There'll be loads of examples both on Canvas and in your workbook. But feel free to go back and you can pause this video at any point and start to try and investigate these formulas. Again, the most difficult bit about solving these problems in any, whether it's statics, dynamics or fluids, is getting your head around what the symbols mean and how to use those to apply the formulas. All right, the maths is easy. One number divided by another number. Primary year 6 stuff. But understanding the symbols and the terminology is where it's at. Okay, so check out the next set of videos on this as we'll start to work our way through and solve some problems. But as always, if you need any help, let me know. And once again, thanks for watching. All the best. Bye bye.